Hello friends. So in this video we are going to discuss a question in which we are given a conducting shell of radius capital R and an external charge capital Q. So we are required to find the potential at point P due to the charges present in the shell. So here in this question we have to apply a very basic concept of Gauss law. What Gauss law states is that the Gauss law states the concept that the potential of a conducting shell inside inside the conducting shell is uniform, it's constant. Also, Gauss law also states that the potential at the center of the conducting shell due to the charges of the conducting shell is kq by r, right? So we are going to apply that very basic concept. So from Gauss law we can declare that the potential at point O, which is VO, we are denoting by VO. V is the potential at point O, is equal to the potential at point P, right? This is this from where we are getting this? We are getting this from Gauss law. You can remember this graph, a very basic graph, something like this, that initially it's constant until capital R, which is the radius of the spherical shell, and after that it decreases by the inverse factor, like 1 directly proportional to 1 by r, or you can say inversely proportional to r. So from Gauss law we are getting this, right? From Gauss law we are getting this concept. Now why we are using this concept? This might come to the mind. So we are using this concept because this point is not special, but this point is. This point O is very special. Why? Because it is the center of the shell. So we can easily find the potential at the center of the shell due to the charges in the shell, right? It's very simple by using a simple basic concept formula of kq by r. So we are going to do that. So now think like this: potential at point O is because of two factors. First, the charge present in the shell, and second, the charge present outside the shell. So there are two charges. So we can write. So the first one I am writing now is the potential due to the charges present in the shell, which is kq by r. R is the radius of the shell. Q is the charge present in the shell, plus now we are writing the charge due to this external charge capital Q, the potential due to this external charge capital Q. So we are writing this K, the external charge here is capital Q, by the distance from the center of the shell, which is 3r. So kq by r, you can write like this, is equals to, now let us assume that the charge, the potential due to this spherical shell at point P is x, right? Now, so actually if you think visually, what will happen is that as soon as we bring this external charge capital Q, the charges will realign itself in such a way that this here in this region the density of charges, positive charges, will be more as we bring closer here, and because repulsion will happen, and you can visualize like this that something rearrangement will happen, but it will happen in such a way that the potential at point O is equals to the potential at point P, right? It will happen in such a way, it will balance it, right? So let us say that the potential at point P due to these redistributed charges present in the shell is x, plus the potential at point P due to this external charge capital Q. Now we are writing this, which is K, the external charge capital Q, by the distance from point P, which is 3r, okay, 3r minus r by 2. What it is? It is nothing but 5r by 2, right? 5r by 2, right? It's 5r by 2. So now this is a very basic equation, algebraic equation, we can easily solve it. So the value of x here is kq by r, we are taking it common out, kq by r, and here taking bracket, and 1 plus 1 by 3 minus 2 by 5, right? So it's very basic calculation. Let me do it here. So we can take 15 as a remainder, sorry, as a denominator. So 15 plus 5 minus 3 to the 6. So if we take approximation, no need to approximate, so 14 by 15, so I can easily see it's 14 by 15. So x is equals to 14 by 15 kq by r, right? So now from here we can find the value of n. We can compare with this uh, equation or this sample concept, this sample answer given here. So the value of n here is 5. 3n equal to 15 and n equal to 5, right? So it's very simple. So the answer of this question is option B, which is 5. Thank you for listening.